So hello everyone. Today's question is implement queue using stack. So let me read the question first. Implement a first in first out queue using only two stacks. The implemented queue should support all the functions of normal queue: push, peek, pop, and empty. Implement the class my class in which these functions are we have to implement. So let's try to do that. And let me show you how queue works. So let me take some operations. So it will be push 3. Then I'm going to push something, two or three values like 16 and then 89, 88, sorry. So let's do that. So our queue looks like something like this. First of all, push 3 will be executed, so it will be push. Then 16 will execute it. 16 is pushed into the queue, then 88, and finally our queue looks like this. Let me comment this and see. Now if I execute a function which calls pop from the queue. So in a queue, whichever element is uh, pushed first, that element will be popped out. So in this queue, which element is we first we are pushed that. So we pushed 3. So we will remove only 3. So it will be like a first in, first out. Then we will, if I again call a function pop, then it will be pop 16 because 16 came first before 88 in the queue. So we left with 88, and if we call a function which is like peak, then it should return 88, which because it contains only one element. So let me push one more element to it. So let's call it 78, and it's 78 pushed into the queue. Now if we call peak function, then it should return 88, and it must return 88. So this is the queue properties. In the queue properties, we can pop only from the front element. That means we only pop the element which came first among all the elements present in the queue. So we have to implement this using two stacks because it is mentioned in the question. We have to use two stack, not the predefined queue in C++. So let's do that. How we are going to do that? So let's analyze what is a stack and how we can use these properties to build a queue. So let me do that for again. Let me do operations for this operations in a stack, and we will see what is the difference between the queue and stack. So first operation is push 3, so I'll push into stack. It will be 3. Now 16, it will be 16 pushed, then 88 pushed. Okay, now it's time to pop. What we are going to pop in a stack, you should remember, in a stack on you can only pop element from the top, or you can say the last element is cam last element is popped from stack, sorry, uh, which is last element is popped from the stack, which is pushed into this stack. So which element is pushed last? Which this is in this case it is 88. So we are going to pop it. Okay, so it will be popped 88. So now this is not the case because we are implementing queue. In the queue, it should pop 3. So 3 is the last element which is pushed. Not last element means I'm saying that 3 is the first element which is pushed, but in the stack you only popped element which is pushed last. So this is the property, and how can we do that? So let me create one more stack which will be stack 2, and I will store that like I'll pop whenever the pop operation is executed, pop function is executed, then what can I do is like I'll take out every element from the stack 1. So let's name it as a stack 1 and push into the stack 2. It will be like 88, then 16, and we have to pop. So I left with one element which is 3, so I have to pop this, and I'll remove this. I'm not gonna push into uh, one second, I'm not gonna push into the stack 2, so it will be removed, and I have a stack 2 of 18 and 16. Now I'll again push into the stack 1. Stack 1 will now looks like 16, and it will be 88. So you can compare, it will be uh, previously stack 1 looks like this. Stack 1 will be like 3, 3, 16, and 88. So as you can see, previously our stack 1 looks like this: 3, 16, and 88. After we call operation pop, then it will be popped 3, and now it will looks like this: 16 and 88. So this is the pop operation, and let's implement this and see it is working or not. So let me comment this, and let me create a two stack 1. Let me call it input. Why I'm gonna call it calling input? uh, let's see in a while. So output, I'm gonna call it output. So I have a stack, one is input and one is output. So whenever I'll push into the input section, input stack. So it will be input dot push x. Okay. Now whenever it times to pop, I'll call the top element, top equal to, I'll call peak first, because uh, the pop function wants to return the top element and as well as remove the uh, from the queue. So I need a top, so I'll call the peak, and then whenever I want to remove an element, then I'll go for output. In the output, I will pop. So output dot pop. Okay, then return top. This is now in the peak section, we have to return the topmost element. So what I'm trying to do here is, whenever the function push is called, I'll push the all the elements into the input section. The output section is only for the removing. So let's say let's say if my input dot size. So in this question it is mentioned that the peak function is called only when there is an element in the queue. So we don't need to check the condition whether the queue is empty or not. So I don't think it's okay. So we don't have to worry about it. So let's try to implement. If my in output, I have to pop, I have to take top element, which is front element in the queue. So I'll go for output output. If my output dot empty equal to true, if it is true, that means I don't have an element in the output, so I have to push the elements into the output. So it will be like uh, for all elements in the input, input dot empty equal to false, then output dot uh, push What we are going to push, it will be input dot top, and then we will pop out from the input dot pop, and that's it. And that at this time we will return output dot top. So this is the implementation of peak. Now if we will check for a empty, return if input dot empty and output dot empty. If my both of the stacks are empty, that means there is no element in my queue, so I'll return the true, otherwise I'll return a false. So let's understand and try on this input and output stacks so you can understand better. So let me create an input stack. It will be this, and one more is output stack. It will be this. So what I'm trying to do is let's take cut this operations and paste it over here so that you can see. So I have this operation. So first of all is a push. I'm saying that I always push the elements into the input stack. So I'll push 3, then I'll push 16, then I'll push 88. Now it's time to call the pop. The pop function is executed. What I'm doing is that pop will call peak function. Peak function is for just taking the front element from the queue, and at that time I'll check if my output is empty, because whatever the output operation is happened is only happened in the output stack. So whatever I'll do, like I will be pop from the queue, then I'll go for output stack. If I want to peak element of the queue, then I'll go for output stack. And if my output stack is empty, then I'll push all the elements in all the elements present in the input stack. So how we are going to push? So 88 88 first popped, so 88 got pushed into the output, will be first, then 16 is pushed and it is also removed from the input, and we have left with 3, so I'll push 3 as well. So my input is empty. Now my output is looks like this. Now I have to popped from the output, and output is popped the topmost element, which is 3, so it will be 3 is popped. Then there is one more executed function pop, so I'll pop the 16 as well. Now it is calling peak, so peak will be like 80 88, and now it will be push. So whenever push function is called, I'll push the element into the input stack. It will be like 78 is pushed into input stack, and if I call peak, so it will go to output stack and ask if it is empty. If it is empty, then I'll push all the elements of input stack into the output, and if it is